Hey, I just wanted to demonstrate the effects of a peltier junction. This is basically, I believe it's out of a cooler or something, one of those portable cooling units that plugs into your car or something. It's a 12-volt peltier. As you know, applying voltage to this would make this side cold, assuming you obey the polarity of the wires, and this side hot, thus the heat sink on this side. Alternately, you could heat up one side and produce a voltage from it, and that's just kind of what I wanted to demonstrate. I have this set on 0.2 volts per division DC. Just gonna grab a match here and stick it under this heat sink. Now this might actually take some time because the heat sink is going to absorb most of the heat and spread it out. But ultimately it's going to get there. As you can see, we're at 0.1 volts DC right now at the moment. And you know what, I think I'll just make this a little easier. I don't want to heat it up too much because it's going to end up catching up to me here. There is, we're at 0.2 volts right now. We're still rather cool in the middle. Okay, there we go, 0.4 volts. I'm going to switch this to a half a volt per division. We are at a half a volt right now. Still fairly cool in the middle. This heat sink's doing a very good job. Although I don't want to wreck it. And that appears to be my limit without getting crazy. It was a little more than half a volt. Now, this thing is rather... actually, it's just warm at the moment. The heat has kind of transferred over to this side a little bit. I'm going to go ahead and heat this back up. And then we're going to apply ice to the opposite side. We're going to heat this side up. And then we're going to apply ice to the opposite side and see what happens. Alright, we are at 1 volt at the moment. This is getting a little hotter than I'd like it to be. That's 1.5 volts. I'm going to go ahead and switch this to 1 volt per division. We're going to apply ice to this side. And whoop, there we go. It's jumping way up. 2 volts, 2.5 volts. Almost 3 volts. Just about 3 volts. We're going to max out at. And that's going to make a nice little mess. This heatsink is very hot at the moment. So obviously the higher the temperature difference between two sides, the more voltage you're going to get. Okay. I have an infrared thermometer here. I'm going to go ahead and get a reading on this. 68.4. 69.3, and on the flip side 64.9. It's still a little cold from the ice experiment. 65.5, but that gives us a pretty good idea of what we're dealing with. I'm going to go ahead and start out by applying and again from my DVD player power supply, plus 5 volts to the peltier junction here. This is a make sure it's actually connected. Okay, and we're going to check it. 72.4, so the temperature is slowly rising. 73.9. The opposite side, you can see that is getting condensation on it. 60.3, 59.3. So this is actually decreasing in temperature, and this is increasing in temperature. What it's actually doing basically is just taking, it's a heat pump, it's just taking the heat from this side and moving it over to this side, which is actually at 79, 81, and 58 on this side. I'm going to go ahead and switch this over to 12 volts, and we're going to go ahead and probably maximize the effects of this. Yeah, I think that's working significantly better already. It appears to be anyway. I could be wrong. Okay, this is 112 degrees, 131, 137. I was kind of looking for 173 because I think it'd be neat to make a peltier still. But as this side gets hot, what's happening on this side? I'm not really getting a low reading on this side, 63, which is, this is actually warming up from the heat transfer all the way through. So obviously the capabilities of these things are somewhat limited, but it's pretty neat nonetheless. And that's peltier junction.